Hi there, welcome to the video. I am Suraj Malvia, a senior software dev and a software consultant. In this video, we are going to peek inside the React Native bridge. Now, before we move forward, if you are watching this video, I expect that you are already developing React Native apps. You have some familiarity with native modules as a concept under the React Native bridge architecture. Over all the years that I have been developing React Native apps, and I have had fair share of my time dedicated towards developing the native modules as well. What goes inside the bridge has always fascinated me the most. Now, while I was studying about the bridge and the internals of how it carries all of the magic that the React Native possesses, I have come up with a small interesting project that could showcase just that. So, without wasting much time, let's get into it. In order to know the contents that flows through the bridge, we need to somehow spy the bridge. Fortunately, in React Native, we have got something called a message queue that represents the bridge in actual and comes out of the batch bridge library from the React Native itself. I've put together a small project and use this the same message queue in order to better understand the messages, to track the messages, to spy the messages, so to say. Let's see how we do that. So there is this utility that I've just created, has three methods: start, stop, and log. What we are trying to do with this is we want to start spying on the messages and also want to append some timestamp so that we understand the chronology of the messages too. Uh, I've got a local array. And it's empty initially, and then what we're doing is, as the messages flows through the bridge, while we are spying, we are just pushing each of the messages with the appended timestamp into the local array, and whenever we want to stop spying, we can just do that. Now, when we invoke the log function, what it would do is it would just iterate over all the local items that we have been pushing when the spy was on, and it would just put it out on the terminal and empties that local queue. So that's about this utility. Now let's look at the example code that I have put together in order to use the utility that we've just gone through. So I've got two touchables here. One is a touchable that has a text called stop spying. Then there is something called a stop show queue logs. There is an increase count button and a text followed with it. So whenever you say increase, it would just increment the integer above it. Then we have some custom native modules showcase as well. Got two buttons that one of them invokes a native add method. We're going to look at that code as well, and then there is another button that has a custom native module attached to it, which is to get the battery percentage. Now let's look at that from the code. So as soon as the app start, we would start spying, as you can see, and then I've got some method coming out of my something called as a my math module. Let's go to this code and see what it does actually look like. So there is this. So you can see this is the Android project of this project. Now there is this math module. It's a typical React Native module, and there is this React method which is called sum. The module exposed is my math module, so it is expecting two integers coming in, and then it is resolving the addition of two integers. So that's what we are going to do here. So the sum in here, you can see there is a handler called on addition. We are doing a sum of 4 and 5, and then whatever the value is, then we are trying to set it as a result state variable. There is this method as well called get battery level. It is also coming out of native modules, and then the custom module is called as my battery module. Let's look at that code as well. So you can see this is again a typical React native module, and then let's try and search the React method in here, which is called get battery level. It is trying to resolve the battery level sync status. So this is just a native code. This is beyond the scope of this video, so I'll just leave it. But what the intent of this code does is, this just fetches the current battery status or the current battery level of the device and returns it. Okay, let's get back to the native React Native code now. So you would remember we have got a stop function, and we have already started spying on the bridge. So let's see how the initial render and the startup would look like if we uh, if we say that I would like to show the messages. Let's go to the console, as you can see, and let's stop the spying and show the logs. So you can see a lot of logs coming in here. Let's this is kind of unreadable for us, so let's copy all of them, and maybe let's put it on the editor and try to see what it actually looks like. So if you see, there are a lot of things that may look familiar. First of all, there is something called as an awesome project, the run application, app registry. So this sounds like the React Native is trying to register the application and trying to run the method called run application out of the app registry module. Interesting bit here is, if you look at all of the messages which are flowing, you would find a common pattern in all of these messages. The first item of all of these messages is a set of arguments that might be traveling from one place to another, and then it is followed with something called as a method and a module, and then a type. So let's start from type. So the type 0 actually the type 0 actually says I'm coming from native to JavaScript. Okay, let's talk about the rendering first. So it's so as you see the UI, you would see something called the React Native Bridge demonstration text being rendered. Let's look at that React Native bridge demonstration, right? So if you look at this specific message, what it's trying to say is, I'm sending an argument with 3 and then RCT raw text and then something called 41 and then text being this, and then what is happening is the method coming in here being create view from a module UI manager, and we have appended the time ourselves, if you remember, and the type is 1. So the type 1 basically tells that it is JS2 native. So what it is trying to say is, hey, could you draw a raw RCT raw text type of an element with the text this using a method create view of the module UI manager. You would come across UI manager thing a lot of times in the whole code, because as it says, it is drawing the UI, because you can see that we have got a lot of UI elements in here. That's about the UI. Let's look at something else. Let's look at maybe, so we have got something called a set children as well. So you would be realizing, okay, it is trying to communicate that I have got a React reconciliation done, because React reconciliation is a part of JavaScript's job. So what actually happens when the rendering happens is, the React would do all the heavy lifting of the reconciliation at its own, and then would try to come up with some set of meaningful instructions, just as you are looking at right now, and communicate the whole thing to native. Now native would pick those instructions, and using the methods described or instructed would do its own work. Okay, let's see what after the rendering what's happening. So this looks like the rendering is done. So you see there is an app state did change event, it's been emitted, and the type is 0. So there is something called app state being communicated from native to React Native, and then some WebSocket failure happening. Let's look at what more is happening. You have got the bundle entry point being set up, then there was a touch start log being generated, because if you remember, we touched the UI a couple of times. Okay, that's good. And if you see, we also incremented the we also incremented the count using this button. So if you see 33 and then RCT raw text and then text being set as 2, this here it is not a create view, it is an update view, because we are not trying to render the view for the first time. Now how do you understand that this view was already created? So if you see the argument RCT raw text 1, this 33 is used in here as well and as well as in here. Let's see where else the 33 was there. Let's see. So there is this 33 with a text 0. So this 33 is basically nothing but a React tag. Now since we have gone through the whole UI rendering logs, it's interesting to dive deep into what these methods would be telling the story. So let's dive into the create view. Okay, so I've got the UI manager module opened here. This is again 68.2 as we are using in the project. The links of the projects, it's already available in the public in the open source on the GitHub, and you can just download fork the project, download it, run it, and you will be able to do the exact same thing. This project is using 68.2 React Native, and just let's see what is the UI manager module. So that's what is open already here. Now we were trying to find a create view method. So very simple way to do that is just find the symbols, and then it's here. So you see it is delegating the create view to the something called as the UI implementation. Let's find that class. The class is already available. I've got it opened already, UI implementation. Now going back to the UI manager, the UI implementation was delegating this task to create view. Let's go to create view under UI implementation and see what it does. So it is saying something invoked by React to create a node with a given tag. So now we know that this parameter is the tag. So if you come back on the bridge and see, the first parameter was going as 7, so it was actually a React tag that was being delivered from React to the native, so that both of the parties actually have common identities of the elements shared. Now let's dive deep further. So this create view of the UI implementation is actually creating a shadow node. Now what is a shadow node? So when the bridge has done all the reconciliation at its own part, like when I say bridge, I mean the React before the instructions traveled from the React to the native. So the instructions traveled all the way to native, and now what the native has to do is native has to craft the UI as per the new tree structure. Since React Native follows Flexbox and native does not know it, because especially in Android we know constraint layouts or linear layouts and so forth. What we have to do is we have to create something called a shadow node, and this is then delegated to something called as yoga. So we can create the nodes according to their properties related to the views, but what the Flexbox things cannot be translated into native is the relative positioning of these elements. That's where a third thread kicks in, which is the yoga. So it's basically a C++ engine. It's available as you can see on my system, a yoga layout. It's a layouting engine. It's available open source, and what it does is it takes the Flexbox inputs and translates those instructions into native platform dependent UI, and what it gives out is relative positioning of the elements. So coming back to the UI implementation, you see we have created a shadow node, and then we are setting some parameters to it. For example, its tag, its class name, root tag, and some context around the theme. Now what we are trying to do is we are registering it against our shadow node registry, and then we are calling something called as a handle create view. Let's get into it. It is delegating it further to something called as a native view hierarchy optimizer. Let's look at this class. I've got it opened already, but as I mentioned, you can again do it like this. You go here and then you say the method was, what was the method again? The method was handle create view, and you see in the handle create view it is expecting a React shadow node, and inside this what it is trying to do is it is again delegating it to a UI view operation queue. It looks like it is trying to enqueue a create view operation. So you see this whole thing is going in a very asynchronous way. We are trying to enqueue a UI operation because the native is not able to depict the whole UI because obviously of the reasons that I have previously mentioned of the Flexbox not being directly compatible to the native. So it is trying to enqueue some create view operation. Let's go ahead and see this UI view operation class which is opened here, and then in the UI view operation what it was delegating to is enqueue create. Let's see the enqueue create view method. In the enqueue create view method it was then adding it to some kind of a non-batched operations and then creating a create view operation object using the parameters it received. So let's look at this class. It looks like a internal class, and then if you look at this class, it is extending a view operation class, and it has a execute method going on here which is now delegating this create view task to something called as a native view hierarchy manager, which is in here. Now if you see the create view in here, you would be able to see you are creating a view using some kind of a view manager. If you look at this class, this is a very interesting class. Let's go to this class. So if you see, this class actually creates the view, and it's an abstract class. If you look at it, what it does is it takes in the parameters, it takes in the properties, and whoever implements this class would delegate the object created to the yoga as a shadow node, and the yoga would then tell, okay, this is the height of the object, this was the width of the object that you've given me. Now the position of this object would be here and here, so xy, and then it is communicated back to React Native with the same React tag, and the UI is then drawn. So this is how the UI manager is doing all of the magic. Okay, coming back to our example, we have seen, what did we see? We have seen the touch, we have seen the initial rendering, we have seen how the text updates, how the properties of the existing element on the screen updates using the set update view method. Update view method can again be traced just like how we trace the create view method. I would say you should do it at your own pace. Now let's move ahead out of the UI and let's see how the native modules, the non-UI modules, are communicated back and forth. Let's start spying again, and let's try to add the integer 4 and 5. So as soon as I click on the button, it just shows me, okay, 4 plus 5 is 9. And as we can see from the code, the math module actually does the a plus b and resolves it on a promise using the native module called math module. Now coming back to the code, and let's look at the code. So what is happening here is, on addition we are calling this sum and we are setting the result. So I would normally expect the bridge to show the content something like some kind of a touch being there, and then the addition of 4 and 5, and then the result. Let's see if we can find math module. Okay, I can see the math module coming in here. So I would say, let's see the touch has started from here, and then we could see the math module. These are the two lines that we would like to look at. So if you see there are two arguments going in, 4 and 5, and then these could be a translated form of promise being supplied. So let's look at the 4 and 5, which are of our interest, and then the method is sum, the module is my math module, and the type is 1, which tells that this is going from JavaScript to native. And then we've got an argument called 9 and the method being depicted as a callback from math module.sum. Okay, this is great because the module is null and then the type is 0. So it tells that there's a callback coming in. Why the module is null? Because the callback from the framework is not module specific, but it's up to the framework how it delegates the callbacks after something has been done executing. So we've got a type 0 message, which means a native to JavaScript message. So this is how the native module invocation would happen back and forth. Same can happen to the, let's look at the battery percentage thing. Let's start spying again and show the battery and then stop spying and let's show that. So if you look at, let's try and find battery, and then you can see get battery level call which was done. Get battery. Okay, so the get battery call which was done, and then there a similar callback for the battery module, and we've got the result as 0.49 something something. So if you can see in the code, we are actually multiplying it with 100 so as to make it 100 base result. So this is how we could have spied on the bridge. You have seen how you can understand the messages flowing in from one end to another end. I hope it was helpful. Again, I mentioned it before as well. The links to this project are in the description below. If it was helpful for you, please give it a thumbs up and share it with your fellow developers or friends. And if you want to watch more of like this, you can also hit the subscribe button down below. Thank you very much for today. Bye bye.